This is Mr. Brain, and this is a quick class tutorial class. I want to lecture you on semiconductors. This is one of the courses that you're going to, be tested on when you write your Jamb or your YA, especially Jamb. So there are not too many questions that will come out on this topic, alright? But at least the few questions that will come out, you should be able to understand what this topic is all about. So I'm going to give you a comprehensive lecture so that you understand it, okay? And it's not just for those who are writing Jamb and YA. For those who also want to learn, the basis of semiconductors. What is a semiconductor? When we talk about semiconductor, the word semi means something that is not fully a conductor. So that a semiconductors are those materials whose conductivity and resistivity are midway between those that are not conductors at all and those who are extremely conductors. Do you understand? So we're talking about materials that are in between insulators or non-conductors and fully conductive materials. So by my right and my left, I have conductors like copper, silver, aluminium. They will have materials like plastic, polythene, and all those materials that do not conduct. You understand what I'm saying? So these ones are in between. So they conduct but not as much as, conductors, and they resist current but not as much as what? Insulators. Now that is by the way. So we have virtually some statements that are very important. Now temperature. How does temperature affect conductors? According to Ohm's law, when you increase temperature, the conductivity of the metal drops. You understand that? Alright? So the resistivity increases. There are two words. Conductivity and resistivity. For pure conductors, resistance will increase when you increase temperature, and conductivity will drop when you increase temperature. You understand that now? Then we say that conductors have a positive temperature coefficient to resistance. That is, increase in temperature increases the resistance, and negative temperature coefficient to what? Conductivity. You understand? So in the case of semiconductors, if you increase temperature, you increases the conductivity. Alright? Because you liberate more electrons that helps the conductivity. That's for semiconductors. You understand? So the temperature coefficient, the temperature has a positive coefficient to what? Conductivity, and a negative coefficient to what? Resistivity. These statements are very important if you are writing exam. Okay, now let's continue. Now we're talking about semiconductors. There are two types of semiconductors, okay? The types of semiconductors are the pure semiconductors and the impure semiconductors, okay? So pure semiconductors are called intrinsic semiconductors, alright? And the impure ones are called extrinsic semiconductors, okay? Now, these intrinsic semiconductors, examples are germanium and silicon. These are solid semiconductors in their natural state. So extrinsic simply means a semiconductor that has an additional impurity to it. Just a small amount of impurity to improve the conductivity. Okay? So we have looked at temperature as part of what improves conductivity of the semiconductor. In addition to temperature, we add impurities to semiconductors to improve the conductivity. And on that conductivity level, we have different things that carry electron or charge. The flow of charge is what generates current, okay? So for conductors, just like we said, for conductors, the thing that carry charge or that flows current in conductors are the presence of what we call mobile electrons. Understanding of mobile electrons means that you understand the metallic bonding, alright? The bonding in a metallic substance, alright? So they have these free mobile electrons around them. Like you can see this aluminum here, they have free mobile electrons, and that is what helps them to conduct electricity. You understand what I'm saying now? Now, in electrolyte, electrolytes are liquid that conduct electricity, alright? Like the one you use in your car. The car battery is made up of liquid, so those are electrolytes. Now, electrolyte allows the flow of current by means of ion. There are two types of ion, the positive ion and the negative ion. So, in question, they can ask you, what is the charge carrier in electrolyte? It is ion, the positive ions and the negative ions. They go either way. Alright, positive will be attracted to the negative terminal and alright, vice versa. Now, in metal, the third carriers, like I said before, is what? Electrons, just electrons, alright? Now, in our semiconductors, it's very interesting. Now we have two third carriers, alright? The first one is electron, as we should expect, and the next one is holes. Very, very interesting to know. The electrons is what gives rise to the holes, alright? Once electron moves, they create a vacancy. That vacancy is what we call holes, okay? At least for this level. Now, the holes is positively charged, since the electron is positively charged. You understand? Are you getting me now? So holes are positively charged and electrons are negatively charged. So there are two charge carriers in semiconductors. Now, in this context, we are looking at how we can improve the conductivity. So we improve the conductivity of semiconductors by increasing the number of holes or increasing the number of electrons. That is to say that in a pure semiconductors like germanium and silicon, the number of holes and the number of electrons are equal. The number of holes and the number of electrons are equal. Alright, I hope you understand that. So, but when it comes to expensive semiconductors, we have what? Look, this word, look, take note. Or doping. Dope means addition of an external material. Alright? So we have doped in these expensive semiconductors produce, a positive type of semiconductor and a negative type of semiconductor. And when we say a positive type of semiconductor, we are trying to say that what is the majority carrier of current? Are you getting me? The majority charge carrier in a p-type semiconductor is the hole, because hole is positively charged. Remember I told you in a semiconductor we have two charge carriers. In the pure semiconductors, the holes, the amount of holes is equal to what? The amount of electrons. Alright? But in this case, in positive type, the holes are more than the electrons, and in the negative type, the holes are, the electrons are more than the holes. So, we say the majority charge carrier in the p-type semiconductors are what? Holes. The majority charge carrier in an n-type semiconductors are what? Electrons. That's all. Alright? So now, what will make a semiconductor p-type and what will make a semiconductor n-type? The material that they are doped with is what makes the difference, okay? In this case, we dope it with what? A trivalent element. So trivalent element are the group 13, okay? So you can use the examples. So we have aluminum, you are correct, very correct. The next one is what? Next one. Next one, I'm hearing. Next one is what? We have gallium. Before aluminum, remember we have boron, right? We have boron. Okay, so they are correct, you can see. So all these elements, they are trivalent. They have 3 electrons in the atom shell. Okay? So when they are added to semiconductors, they create a positive type semiconductor. Remember, P stands for positive and N stands for negative type semiconductors. You're getting it now. I like that. Okay, now for N type, if you want to create an excess electron, you have to add a material that will create that avenue. Okay, so in this case, you can see we put trivalent. Mind you, a pure semiconductor silicon is just tetravalent. So you now come and add a trivalent element, trivalent. So it's like really creating a vacance for one more. So that's why holes are more. Now in this case, you add a pentavalent. That is, you add the 4 and add extra 1. Pentavalent. 5. Pentavalent. So give me examples of pentavalent elements. I know you are very smart. Okay, I'm hearing you. Pentavalent. Pentavalent. Yes. Smart people, help me out. Phosphorus, God bless you. So what? Arsenic. Oh, God bless. Arsenic. The next one. Oh, antimony. I can hear you very loud and clear. Antimony. Antimony is SB. Sorry. SB. And many more. Okay? Want to talk about the test areas. I told you that the test areas here, the majority test areas is what? Holes. And the majority test area here is what? Electrons, right? Please, majority test area. That's the word. Okay? Want to look at the diodes. Okay? What is a diode? A diode is when you have a combination of a p-type and an n-type. Okay? So that will create a junction. A junction I will call p-n junction. p-n junction. So p-n junction is just a tiny boundary between your p and your n. Your p and your n. So now, we want to give a symbol to it. This is the symbol associated with pn junction. You can see. You can see the symbol. Right? I know you understand the symbol, right? Good. Now, a diode would, number 1, rectify current. If you rectify current, that means it will move an alternative current to become a direct current. So it converts AC to DC, alternative current to DC. That's the majority function of the what? Of the diode. You can see a diode, right? So now, the next one is a transistor. Let me use the word transistor. Remember, this is a diode. We have a transistor. Plus, a transistor does what a rectifier does. Alright? And we have 2 types of transistor. A transistor could be in this form. It will have a p-n junction twice, okay? To have a p-n junction twice. So we have NPN, and we have PNP. This is what we call a transistor. You already know the meaning of N and P, right? So what's the majority function of the transistor? The transistor does more than just rectify. It also amplifies current. Okay, it amplifies the current. Are you getting it now? So now a transistor consists of 2 junctions. You can see that, right? So a transistor will be in this form. The sign of the transistor, or what do you call it? The symbol is, I want to draw it this way. We have a base, alright? Then An emitter. Then we have a collector. Remember, this is a base. Okay? So when it's starting this way, when this emitter is starting this way, That is an NPN. Why? Because the positive terminal must be connected to the emitter. Please take note. Positive terminal must be connected to the emitter. That's why it's starting to. So if you go the other way around, it goes the other way around. You have your emitter here and your connector here. That will be a what? PNP. So that's just the basic knowledge. Now I want to show you something that is most likely going to come out. They're going to test me on. Now we said that diode improves changes current from AC to direct current, right? Now I will say that transistors does what? Amplifies current. Now you need to see the diagram. In the diagram that shows the application of transistor, so we have your negative, positive, and positive, negative. So how does transistor improve, amplify the current? So this is an IV, that is a current voltage, what? Graph for transistor. So the current goes this way and is amplified. Please take note. This is the graph that shows what? The amplification of what? Current by a what? Transistor. So when we talk about forward bias and reverse bias, we are dealing with a diode. Alright? Remember, our diode is something like this. Our diode just have, one PN junction. So N, P or PN. Anyone. Whichever one, they are the same thing, because you can also invert. You can turn it off that way. Alright? So now, what is a forward bias? A forward bias is in the case, where you connect this positive part to the positive terminal, and this part to the negative terminal. Remember, the longer side of this cell is the positive terminal, the shorter side is the negative terminal. So when you connect it like this, you're going to have a very large output of current. The current is going to go this way. Current moves in opposite direction of electron. So the current is going this way, electron is going the opposite direction. Current always goes this way. Please take note. So when you now have a situation in this format, let me do it this way. When you have your negative terminal here and your positive terminal here, you can see. So in this case, we have little flow of current. Look at the diagram. You can see the diagram. That's the galvanometer. I hope you know. So the galvanometer is going reverse way. And this galvanometer is going. Now, this galvanometer will read little amount of current. All like this. Now, for this, the current we are having a large amount of current here compared to this. Because in this case, the holes are repelled by the positive terminals. The holes are repelled by the positive terminals, and the electrons are repelled by the negative terminals. I hope you understand. So that's just a short lecture on semiconductors. So I hope you understand it. Please share this video so that your friends can learn, and giving you the basic diagrams to help you to pass your Jamb exam.